So we started this afternoon with an ArcGIS demonstration on search and rescue. But our next presentation uses the platform, but in their case, the mission of this organization is to prevent a search and rescue mission from ever being required. So please welcome from the National Hurricane Center Storm Surge Unit, Jamie Rome and Bobby Luangsai Songkram.
So this audience can appreciate behind every hopefully good presentation, there's a brilliant technical person making it happen. So Bobby and the other presenters, Ethan and William, responsible for making this hopefully a good presentation. So I'm really excited to talk to you about all the exciting work that's going on at National Hurricane Center with respect to storm surge forecasting. And I think everyone here can also appreciate that in the aftermath of Isaac and Sandy, storm surge has been thrust to the forefront of our mission. And I'm a pretty busy guy these days. But before I get started, I need to sort of explain to you the context of what we do at the National Hurricane Center. I think most people are really familiar with the hurricane forecast itself, the cone that you see or know and love on TV. But we also have this very large mission with respect to storm surge. So during an actual event, just about all information supplying or emanating through the media, through the emergency management community, through the national government, comes from the National Hurricane Center. We're sort of the tip of the spear, if you will. So we have that mission, which is I think, a bit obvious. We also have an off-season mission. How many of you knew that the nation's hurricane evacuation zones are based off storm surge? And that the modeling that goes into defining that comes from the National Hurricane Center. So that's a big-time off-season mission. And then I zigzag across the U.S. giving talks like this, except to practitioners. So we do a big education and outreach effort. So we do this via a suite of products, ranging from the complex to the simple. So we start in the left-hand side of this image. The MOM, the so-called MOMs, the maximum of maximums as we call them, is a worst-case storm surge scenario, worst-case storm surge flooding, based off of the several thousands of hurricanes hitting the coast. This is what goes into developing the evacuation zones. Then we move to the real-time products that we use to sort of map the individual hurricane that's threatening the coastline. That's the MEOW, in this case the P-Surge, which is the probabilistic storm surge forecast. And finally, our keynote product for the general public and the media, which is the text advisory or the public advisory. So there's our suite of products. And one sort of has to move through these products as the hurricane evolves, which is a complicated sequence of steps. So let's take a look a little bit closer. Let's start with the text product. Now, this is an example from Sandy. You can look at the forecast in there if you want to. It's an incredibly accurate forecast looking back. But what's wrong with this product? It's text. How does anyone map this against the types of information that emergency managers or decision makers might need to use? For example, evacuation zones, shelters. It'd be really hard, even with an accurate forecast, to use this information. Well, what about some of the other products I showed you? What about the MOM? Again, the MOM was the maximum of maximums, or the worst case scenario. So what I have here is the evacuation zones, the hurricane evacuation zones, which are preset for New York City, which is in Manhattan. So you have A, B, and C. These are preset zones. And then we have the MOM mapped over top of it. So this is the native model resolution, the native storm surge model resolution. Now, can anyone see a problem here? It's very clear that the native model results do not meet the needs of evacuation decision makers. It would be very hard from this depiction to determine whether to pull the trigger on A, B, or C. Now, this is a tens of millions of dollar decision affecting thousands of people. Evacuating Manhattan, and this is just one example, is a pretty big decision. I think we can all agree on that. And yet it's very hard to do with our current suite of products. So this has been sort of conceptual. Let's switch to a live demo, which Bobby's going to drive, and we can look how this might play out in an actual storm, specifically Sandy. So this is Sandy about 36 hours prior to landfall. You've got the famous cone of death there that we typically use to show where the center is most likely to go. And then you have our probabilistic. Remember, I introduced you to the probabilistic storm surge. behind me in the color. So bright colors equals worse surge. So if we focused in a bit more on New York City, you see the exact same problem that we had with the MOM. The native resolution of the storm surge model is too coarse to make an effective decision at the local level. Indeed, it would be very, very hard to pick which evacuation zones, which are showed to you in the shaded purple, again, A, B, and C, which to choose. Now, a lot of people come up to me very flippantly and say, well, why don't you just make your model higher resolution? That'd be all well and good, except making models high resolution takes extensive computing effort, which I work in a line of work that I only have seconds to minutes to make a decision, not hours and days. So what we've done to overcome this is to use ArcGIS to downscale the native model resolution. So in this case, Bobby's going to input PSER. It's a probabilistic product I talked to you about, the coarse, blocky depiction that you just saw. He's going to pick his area, in this case the Northeast, because we're doing Sandy. And what he gets afterwards, after we've downscaled it, is a much more refined depiction of storm surge. I think everyone here, you don't need to be an emergency manager or a storm surge expert. You could quickly determine which evacuation zone was most a threat. In this case, the majority of the risk is contained in Zone A. But this is not the only decision emergency managers have to make. For example, let's say you've gotten over the hurdle of pulling the trigger on an evacuation. You've got to send those people somewhere. You've got to put them on the road, which means you might need to know the evacuation routes, which are shown here in black lines, and the evacuation centers themselves, where you're going to send them to. But that's not the real beauty of this vision. The real beauty here is not just overlaying layers. We can almost do that now. The real beauty is empowering the emergency management to do analysis on their own. For example, what if they wanted to run their own tools, their own analysis, to determine which of those evacuation routes might be most likely to be needed, and which of those zones, which of those centers people were most likely to evacuate to. Now, this is just one demonstration of the many types of decisions we envision empowering the emergency management community with making. So to sum this up, it's really about communication. It's really about making complex data sets, which are models, into more readily available data sets in a way that people can use it. And that's converting it from the native coarse resolution to a finer resolution to meet our users' needs. And it's really about understanding what's in that middle picture there, is helping the decision makers envision what will be the impacts on the ground and what type of impacts they would expect from a hurricane. So with that, I'm going to wrap things up. Thanks, John, for the opportunity to be here with you today.
Thanks. Thanks, Bobby. Thanks, Jamie. It was a pleasure having you. When you imagine how we can integrate all this rich scientific analysis with our rich geographic data, that's how we can create actionable intelligence that allows local officials to make the right decisions and to communicate the urgency of an event.